Hey everybody. So today we're going to be taking a look at some of the crashes that we got in last week's episode. So if you didn't watch that yet, I recommend you do. We're taking a look at trying to find some zero-day vulnerabilities in the Radare parsing of some of the file formats they support. In that first episode, we took a look at how to get Radare to build for AFL. And in this episode, we're going to dive in and we're going to start looking at some of the crashes that came out of AFL. In any case, let's go take a look and see how things went.
Hello, everybody. So, as you can hear, I've got a little bit of a cold still, so I'm going to start by apologizing for that. Hopefully it isn't too difficult to listen to. But it's been a little while since we got started on all of this. If you remember from last time, we were in here and we were doing some fuzzing of Radare. Now, it's been about 2 weeks now. It's longer than I had intended. My original intention had been I'd let it run for about a week, and then I'd come back and do the recording and get all that done, but turns out this cold did not appreciate that at all. So, in any case, we got quite a bit more time to run, and in effect, we got a lot more crashes because of that. Let's do this real quick. So if we do cat F1, the fuzzer stats, you can see on this one we got about 35 million. Yeah, about 35 million test cases done. If we look at all of them, execs done /fuzzer stats. Looks like we had, what is that? 35 plus 38 times 4 plus 34, 29, 34 plus change, so a little bit under 400 million test cases run through here. So quite a pretty good what I'm looking for here. Pretty good throughput. It is worth noting that even with that many executions, we still only got zero cycles done on our main thing, which I believe means that we still haven't gotten through all of the potential mutations for that first thing. And for those curious, this minus this in seconds. So yeah, it's running just under 14 days. You'll note that the reason it's a little bit under 14 days like that is because I actually had to reboot this because of the Windows updates that just went through. When I got all those installed, I ended up rebooting, and that's the one that broke all the certs. Well, fixed breaking all the certs. So, in any case, we've got tons of test cases, and we also got tons of crashes. If we want to look at the number of crashes, in total we have, what is this actually called? Unique crashes. We've got, just rough order of magnitude here, 1,000 unique crashes is what AFL thinks. Now, these are not all real crashes. So, the first thing we're going to have to do here is we're going to have to actually go through, triage these, and get some crashes out of them. So, you'll see over on the right, like I've been trying to do more and more often, we've got a little bit of a to-do list for this episode. Right now, we're talking through the crashes. After we do that, which we're basically done with now, the next step is we're going to put together a triage tool. So, a tool to actually go through and pull out the results of each of these inputs. We're probably just going to build that with a simple bash script. But unlike some of our previous times I've done some fuzzing on this channel, the next step is we're going to actually build a database for these. Usually we've had a sorry about that. we've had a relatively small number of crashes to deal with. But in this case, we've got those numbers look like about 1,000 to me, which is a whole bunch of crashes to try and go through. So rather than trying to get through all of those manually, we're gonna build a little bit of stuff to try and help us get through them a little bit more quickly. And after that, once we get all this done, get a handle on exactly how many crashes we're actually looking at, then we can start triaging the crashes that we have. So let's get started with that. Let's mark this one as done. So just so everybody's on the same page, the way that we're going to do this is if we run this, that's Rabin, which is the Radare binary information tool thing. If we go into -I is printing out headers or something of that sort. If we run these through, we should get information like this. So if you run it in GDB, if we do a r-i 1/crashes/id 1, 2, 3, 4, 5, 6 star, this would actually give us where we're at. And you can see in this one, it looks like we probably have an out-of-bounds read, just based off of what this is here. That's a macro plus some variables here. And if we do the actual instruction, I need to fix that before I go crazy. We're reading from RBX, and RBX is a null deref. Okay, which probably has to do with this assert. My guess is that they've got some assertions in place that are set to just warn in whatever type of build we have rather than actually breaking. And we triggered it, and we fall in here. Anything else that's interesting? Looks like we actually generated a UUID. I'm not sure exactly what that is in this format. Yeah, this is basically what we're going to do. We're going to write some scripts to go through. We're going to process all of these. We're going to pull them out. And the idea is that by doing that, I can't manually go through 1,000 of these. It's going to take me a minimum of, if I got really good at this, let's say I could do 1 or 2 a minute. That's still 500 minutes, 10 hours of processing to do them all manually, and that's if all of them are useless. So instead, we're going to build some simple scripts to try and do this much more quickly in an automated fashion. Where did that get hidden? For anyone curious, this right here is the album we're currently listening to. That's the album art for it, and it should update for us, assuming you're watching the version of this that has the music attached to it. So, I guess one more thing we can do here is to actually show you. So, these are all our crashes, and one of the things that's interesting is file doesn't actually think they're anything, at least not for the most part. If we go into the queue, we have a huge queue. Some of these, it's identifying as actual types. Now, whether or not these are real is another question. You'll just bear with that coughing. I'm hopefully going to cut it out of the final version, but we'll see. There's some image formats, which I think they handle. A Plan 9 executable is actually plausible. Some MS-DOS executables, those are very plausible. I think that probably just needs the MZ header. I assume the Plan 9 executables are similarly very simple to create. That's interesting. This bunch of gibberish. But anyway, that stuff. Let's actually get started on that. So the first thing we want to do is we want to write a GDB script. And if I remember correctly, we can do a GDB dash, is it X? Yeah, -X will execute a series of GDB commands. And if you remember, we wanted each of the commands to be was a... Actually, let me think about this for a second. So, the way that we're currently doing things is we'll take we would pass in a -R. Is there an easy way from, like... Yeah, unfortunately, I think we're going to have to generate our file every time so that we can pass in which file to actually execute, which is not ideal. But, I guess let's do that real quick in Python. So first we're going to make a directory here. It's a triage directory. We're going to store all our results. You know what, let's put it in here. So we want... Which version of Python am I running? Okay. Okay. So, triage... So, crash list is equal to... how do I want to do this? Whoa. Okay. Okay, so it won't accept things directly like that, which is good for us to know. So yeah, we'll just do this manually. So I'm using Vim macros. To do this, rather than having to type that out manually. So fuzzer plus slash crash slash crashes. Okay, what does this leave us with? Yeah, about 1,000 of them. Actually, what do these actually look like? That's what I was afraid of. Oh, that's good at least. So it's not including those directories. So we're using a list comprehension here to get the thing we actually want. Which is, these are actually paths that we can use. See, these are now with the full directory names. So, if we come back in here, we can go ahead and keep that in. I really need to learn the new way of doing this in Python 3. The format strings for it are apparently slightly different, and I still haven't gotten around to learning how to do them right. So, we have our list of crashes. So for crash in crash list, what are we going to do here? So now we need to actually build out one of those scripts to run, to actually do a thing. Let's actually put that up here. So our TV script is going to run our thing. I always forget how to do this. So we want to set logging on and then set a file to do it in. Set logging file. So we turn on logging, which is going to log the output of GDB. Then we're going to run it with our thing. We want to I just want to make sure this runs real quick. Yeah, that looks right. So what we just did there is we set up a GDB init file so that I don't have to keep swapping out the disassembly flavor. So back over here, we do this. I want to get our RIP, which is our current program counter. And I also want to do IR, and then we'll quit. And I believe that's basically all we want to do. Yeah, so I think that's about what we want to do here. So, one thing that's worth noting is we don't want to set the logging file to be this thing. So I'm just going to use a SHA-256 just because it's going to be relatively quick. So triage/out/%s, where this is hash hash lib.sha256. crash.hexdigest. So we're just going to generate a SHA-256, which is going to be the hash for this specific crash. Our GDB script is going to be GDB script. We're going to fill in those two arguments, so log name and crash. So we're filling in this bit and this bit. So we're going to open we're going to write our GDB script to it. And we're going to break. We're doing this so that I can test it and make sure this works. Set logging on. That looks pretty reasonable. And I want to then run robin2 -x gdb.script. Oops. Triage/out. And we want to do this. Huh. Set logging on, set logging file that. Oh. Okay. Weird that you have to do it in that order, but okay. So, this gave us... does not have the input file in it. But we do have the instruction we crashed on. If we had source code for it, we would have that there. And then we have our actual dump. In this case, we're raising an exception. Oh, we probably want to get a backtrace too while we're at it, don't we? So, things we need to fix here. This needs to go here. We probably want to do a... Okay, that works fine. So, we're putting crash twice. So this will now print out what crash we got at the start of this file. Okay, let's try this one. Well, this is not good. This is better. So why isn't that doing a new line? Okay. No, so I do just put a slash ad. Would help if I did this right thing, wouldn't it? So, let's say Unicode object. So it still isn't doing it quite the way I want. Oh, because it's actually putting them in. Duh. Yeah, that looks like what we want it to be doing. There we go. This looks like basically what I want it to be doing. This is in a format that we can actually deal with. Okay. So there's still one thing we have to think about here, which is going to be a little tricky, which is how to process some of this stuff. But rather than doing that right now, so we're not going to do that. Instead, we're going to do Python 3. I want subprocess, but I want I don't want to with async IO. I want so run is new, isn't it? Yeah, run is brand new. Run the command described by args. Wait for it to complete. We don't care about the output. let's do that real quick. So import subprocess subprocess.run gdb dash batch dash x gdb.script robin2. I believe that is what we wanted to run. We want to do, we don't care about any of the output. We do want to timeout. Timeout is in seconds. Say 60 seconds apiece. That seems reasonable. Let's see if this works now. Looks like what we want. So we'll get rid of this. Awesome. So this should go through now. It's going to take... I mean, I know some of these are going to hang and take the full minute. So let's say this is going to take... These are 5 seconds apiece, 5,000 seconds. It's going to take a little while. So I think we're going to end this episode here. We're going to call it a day. So we built our triage tool. And I can come back in a few hours or tomorrow or something like that, and we can pick up where I left off. And we'll build the triage database and actually start triaging some of these. In any case, thanks for tuning in, everybody, and we will talk to you later. Bye.
Hey, everybody. So this was a little bit of a shorter episode, but hopefully it was still entertaining for you. We were able to go through and we went through several of these crashes, and we were able to determine that while there are quite a few crashes, there are enough crashes that we can't really do this manually. We're going to have to build a tool to go through and do some initial triage of all these crashes first. In any case, hopefully you learned something taking a look at all these crashes, and if you learned something or you found this to be an entertaining video, I'd really appreciate it if you tried to support me over on Patreon. There's a link down in the description down below. In any case, I will see you all next week. Bye!